Hello everybody. In the coming videos from this video onwards, we will be discussing few questions every day connected with the different admission tests regarding the physics, mainly the JAM. So we will start with a few questions from mathematical side, mathematical physics side, and then we will progress on to other topics in the questions that is normally encountered in the JAM or similar type of admission tests. So let's start. We see few questions and we try to solve these questions. The first one is this. As you see here, f of xy is given by this. Now we want to have the curve along which this del square f is equal to 0. Few answers are given here. We have to pick the correct answer. This is a easy question. We know in 2 dimension. Here the function is in 2 dimension x, y. So we consider the del in 2 dimension, which is I dou by dou x plus j dou by dou y. If it is in 3 dimension, we will have k dou by dou z also. Del square is del dot del. We know del square is del dot del, that is dou square dou x square plus dou square dou y square. So del square f will be dou square dou x square plus dou square dou y square of this function x cube minus 2y cube. So we have to partially differentiate with respect to x 2 times, with respect to y 2 times. As we differentiate this with respect to x 2 times, we will have 6x, and here we will have 12y, and del square f equal to 0, so this is equal to 0. So from this we will get x equal to 2y. So in this, the option B is the correct answer. The second question, a curve is given by r of t. Okay, r of t, that is ti plus t square j plus t cube k. So this is the x component, this is y component, and this is z component. That's why we have I, j, k here. Now the unit vector, unit vector of the tangent to the curve at t equal to 1. Unit vector of the tangent to the curve at t equal to 1. That has to be determined. The tangent is given by dr by dt. So here this is r, it's a function of time. The tangent, that is given by dr by dt. So we have to differentiate this thing with t. So we will have I plus 2tj plus 3t square k, and we know we have to determine it at t equal to 1. So dr by dt at t equal to 1, that will be I plus 2j plus 3k. So this is the dr by dt at t equal to 1. Now we have to find unit vector. So how can we find unit vector? We divide this vector by its magnitude. Okay, its magnitude is root of 1 plus 2 square plus 3 square. Okay, magnitude of this root of 1 x square plus y square plus z square. So this is I plus 2j plus 3k over root 14. So in this answer D, this is the correct answer. Now the third question, which one of the following curves correctly represents approximately the solution for the equation df by dx plus 2f equal to 3. df by dx, f is a function of x, plus 2f equal to 3, where f of 0 is 0. Okay, so 4 curves are given here. We have to pick the right one. So here you should know how to integrate an equation like this: dy by dx plus p of xy equal to q of x. Suppose we have a general relation like this. When we try to find this y, the first thing that we do is we find the integration factor, which is exponential integral p of x dx. Okay, this is a standard method. You find the integration factor, which is in exponential integral p of x dx. Then d by dx of this y into this integration factor. Okay, we have to apply the product rule. So first thing will be what we are doing is we are multiplying the entire equation by this integration factor. Okay, we have to multiply this entire equation by integration factor. So on the left hand side you will have d by dx of y into the integration factor. Okay, so you just apply the product rule. So integration factor dy by dx plus y into d by dx of integral p of x dx. So you will have p of x here. Okay, so if as we integrate this, you will get if into y. On the right hand side, integral if q of x dx, this integration plus c, a constant. Okay, so this, and from this y can be obtained. Same thing is done here. For this equation, the integration factor is obtained in e raised to integral 2 dx, which is exponential 2x. So you multiply this thing with the entire equation and you will get this thing. So y into y is f here, f into the integration factor, that is equal to integral exponent the integration factor, the q of x here is 3. Okay, 3 dx plus c. You integrate and you will get 3 by 2 e to the power 2x plus c. And we know x equal to 0, f of 0 equal to 0. So this can be used to obtain c. So c is minus 3 by 2. So you will get f of x is equal to 3 by 2, 1 minus e to the power minus 2x. And when x equal to 0, from this we see f of x 0. And when x is infinity, this term will be 0. So you will get 3 by 2. Okay, and due to this e to the power minus 2x, 1 minus e to the power minus 2x, that will be actually varying like this. Okay, 1 minus e to the power minus 2x will be varying like this. And when x is infinity, we saw here, when x is infinity, f of x is 3 by 2. Okay, so this will be correctly expressing this curve or the solution of this equation. Okay, when x is infinity, it is 3 by 2, and x is 0, it's 0, and due to the 1 minus e to the power minus 2x, it will be varying like this. So not this one, it will be this one. So the correct option is B. Another problem is this: which one of the following graphs represents the derivative f prime of x df by dx of the function f of x equal to 1 by 1 plus x square most closely? So this is the function. Okay, this is derivative. It is easy to find the derivative. You just take the derivative. We know this will be minus 1 minus x square to the power minus 2 into 2x. That will be the derivative of it, f prime of x. That is equal to minus 2x by 1 plus x square. And we know this is an odd function because of this minus term here. This is actually an odd function. So the derivative is an odd function. And option C and option D are actually even functions. You can see it is even function. When x is positive or negative, f prime of x is positive. Okay, so this is an even function. The same value we are getting. And here also this is an even function. X is positive or negative, is positive. Same value we are getting. So these are even functions. So you can these options are wrong. And in this, we see if here if x is greater than 0, if x is positive, df by dx is negative. And if x is negative, the df by dx or f prime of x will be positive. Okay, so that is applicable to this one. Yes, when x is, this one, when x is positive, f prime of x is negative. When x is negative, f prime of x is positive. So this one, option A is the correct answer.